Hi everyone, in this video I'll be talking about 9.5. This can be a challenging section. I definitely appreciate that. I remember word problems for me were challenging for sure back in the day. They still can be. So let's read this. It says, during the first part of a canoe trip, Ken covered 60 kilometers at a certain speed. He then traveled 24 kilometers at a speed that was 4 kilometers per hour slower. If the total time for the trip was 8 hours, what was the speed on each part of the trip? So what I'll do is kind of this formal approach. So we have two parts. We have this first part of the trip, and we have a second part of the trip. So what I'll do is kind of define variables with respect to these two different parts. The governing equation for this first problem would be d equals r times t. In other words, the distance that you cover depends on your rate times your time, right? And we probably all kind of know this. Back when we used to drive places, like if you drive 30 miles per hour for 2 hours, then 30 times 2 would tell you that you went 60 miles. Or if you walk 5 miles per hour for 3 hours, then you would have gone 5 miles per hour times 3 hours, that's 15 miles, right? So distance equals rate times time. So in these two pieces of this story, this d equals r times t is going to be important for us. So again, it said during the first part of the canoe trip, Ken covered 60 kilometers. So I know the distance for that first part is 60. So I'll say 60 equals, right? D equals, so 60 equals at a certain speed. So I don't know what speed that was. So I'll just label it as R1, right? The rate for the first part of the trip. So this is just the rate for that first part. I don't know how long. So I'll just call this T1. So 60, the distance for the first part, equals the rate for the first part times the time for the first part. Okay, the second part then traveled 24 kilometers. So we'll have 24 equals. And now it says 4 kilometers per hour slower. So if I take R1 and I subtract 4, that would be the rate that the second part of the trip involved. Okay, and I don't know how long Ken was traveling this fast, so I'll just say T2. Right, so we have two equations, and I have 1, 2, 3 unknowns, right? R1 is here and here, that's one unknown. T1 is another unknown, T2 is another unknown, so I have 1, 2, 3 unknowns, and I only have two equations, so I need another equation, right? There's a number I have not used, this 8 hours. So we know that T1 plus T2, in other words, the total time for the trip, is this 8 hours. So I know that T1 plus T2 is 8 hours. I don't know exactly how much T1 is and how much T2 is, but I know that they total up to 8. Okay. So what I can now do is eliminate T2, let's say. So I know from this, if I subtract T1, I would have that T2 is the same as 8 minus T1. So I can substitute that in for T2. In other words, this equation can become 24 equals R1 minus 4 times 8 minus T1. Right, I'm replacing T2 with 8 minus T1. Okay, so now I'm looking here, and I'm looking here. So I have these two equations, right, 1 and 2, And I have two unknowns, right? I have R1, T1, R1, T1. So from the first, I can say if I divide both sides by, let's go ahead and divide out, I'll have 60 over R1. In other words, if I divide both sides by R1, that'll be equal to T1. So what I essentially have is this system of equations, these two equations, and I want to use substitution. And what I now can do is place this in for T1. Right, that's substitution. This is basically solving a system of linear equations in two unknowns using substitution. So that would create 24 equals R1 minus 4 times 8 minus 60 over R1. Right, I replace T1 with 60 over R1. Now I have one equation and one unknown, R1. Okay, so I want to solve for R1 now. So let's see, what I'll do is I'll FOIL. So if I FOIL this, we're going to get 24 equals R1 times 8. So I'll have 8R1. Now the outside, I'll have R1 times negative 60 over R1. These R1s will cancel, and I'll just get negative 60 out of that combination. Right, the inside combination is negative 32. Right, negative 4 times 8. And then negative 4 times negative 60 over R1 creates negative 240 over R1. And I'm solving for R1, keep that in mind. So maybe I'll combine some like terms now. So we'll have 24 equals 8R1. Negative 60 minus 32 is negative 92. And then I still have plus 240 over R1. Maybe I'll subtract over this 24. So negative 92 minus 24 is negative 116. So now we have 0 equals 8R1 minus 116 plus 240 over R1. I have R1 down in the denominator. So imagine that were x, I'd want to multiply through by x. So I'm going to multiply through by R1. Both sides. So distributing R1, I still have 0 on the left. And now I have R1 squared. So I'll have 8R1 squared, right? Because R1 times R1. And then I have negative 116 times R1. So minus 116 R1. And then R1 times 240 over R1 will just be 240. So this is, let me move this 1 up a little bit because that might be confusing. It's just the 1 there. So 0 equals 8R1 squared minus 116R1. R1 is our variable, and then we have plus 240. So it looks like I can solve this. Maybe I'll just divide out by 8 first. So let's go ahead and divide out by 8 everywhere. So I'm getting 0 equals R1 squared. Negative 116 divided by 8 is negative 14.5. R1. And then 240 divided by 8 is 30. So now you're welcome to use the quadratic formula. you can say A is 1, in other words, this one. B is negative 14.5. And C is 30. So I'll use this other piece of paper to do the rest of the work. Okay, so I'll have that R1, which is our variable, equals the opposite of B, so 14.5, plus and minus the square root of negative 14.5 all squared, minus 4 times 1 times 30. Right, 30 there. And then all divided by 2 times 1. So I'll type that in now. So fraction 14.5 plus square root negative 14.5 squared minus 4 times 1 times 30 all over 2 times 1. So I'm getting 12 for the plus case. So R1 plus, if you will, is 12, and this would be kilometers per hour. Right, so that was the rate for the first part of the trip, actually. So this first part of the trip, we just figured out what R1 was. Okay. It was given that R2 is 4 kilometers per hour less than this. So R2 would equal 12 minus 4, in other words, 8 kilometers per hour. So first part was 12 kilometers per hour, and the second part was 8 kilometers per hour. All right, if you check the negative, so remember I didn't check this negative case. If I go back and check it, so subtract instead of plus, we're getting 5 halves, right? But if R1 is 5 halves, if I subtract 4, I now have a negative number, which doesn't make sense actually. So the negative case just doesn't yield anything that we actually cared about. So it's just the positive case. All right, so on to example 2. It says Stan's Subaru travels 280 miles, averaging a certain speed. If the car had gone 5 miles per hour faster, the trip would have taken 1 hour less. It says find Stan's average speed. So we have kind of one part of the trip and then this hypothetical other part of the trip. So for the first trip, we'd have, again, this d equals r times t is playing out. So we have Stan Subaru traveled 280 miles. So 280, that's d, equals, sorry about the, looks like it's going in and out of focus. And then at a certain speed, so I'll just call that R1. And we don't know how long that took, so I'll just call it T1. The second part of the trip, or not the second part, but if the trip would have taken place again, just with things changing. So it says if the car had gone 5 miles per hour faster, so if we're still going 280 miles, if I take R1 and add 5, then it says that the time, and we called that T1, would have taken 1 hour less. So we would have had T1 minus 1 in that case. So I have 2 equations, and I have one, right? This is one unknown, and this is 2 unknowns. So I have 2 equations, 2 unknowns. In other words, I can solve. So from this, and we want to find the average speed, so we want R involved still. So I'll divide both sides by R1. So we'd have 280 divided by R1 equals T1. And now I can use substitution again. And I'll take this thing and replace T1 with it. So in other words, we have 280 equals R1 plus 5 times 280 over R1, right? Replacing T1. And then I still need to subtract 1. Solving this for R1 in a similar way that we did the one above. So I'll go ahead and FOIL this out. So I have 280 equals R1 times 280 over R1. Those R1s cancel, and I just have 280. The outside, R1 times -1 is negative R1. The inside, 5 times 280. 5 times 280 is 1400, so I'll have 1400 over R1. And then last, I'll have 5 times -1 is -5. All right, I'm solving for R1. Maybe I'll go ahead and subtract the 280. So I'm seeing 0 equals negative R1 plus 1400 over R1 minus 5. Right? And what I'll do again is I'll multiply through by R1. So distributing R1 again. So I get 0 still, R1 times 0 is 0. So 0 equals negative R1 squared, R1 times R1. Then distribute R1 to this term, I just get plus 1400 because the R1s cancel. And then R1 times -5 is -5 R1. And then just rearranging things, I have 0 equals negative R1 squared, that's my squared term, minus 5 R1, and then plus 1400. Okay, so you can now use the quadratic formula. You have, again, a quadratic equation in the variable R1. So I can say that A is -1, B is -5, and C is 1400. So R1 would equal the opposite of B, plus and minus the square root of B squared minus 4 times -1 times 1400, all over 2 times -1. So typing that in fraction bar, 5 plus square root -5 squared minus 4 times A times C over 2 times -1. So I'm getting -40 there. If I go back, really I only want the positive speeds. So that might be mathematically true, but it wouldn't make sense to say that negative speed, so it must be this one that we're after. So actually in this case, I'm eliminating the positive case. So it's R1 minus. So R1 minus equals, this would be 35 miles per hour. Okay, and that would be the average speed. That's it. Okay. So on to page 127. So this one says, the product of 2 consecutive even numbers is 360. It says find the numbers. So I don't know what these numbers are. but I know that they're even consecutives. So even consecutives would be numbers like 2, 4, 6, 8, 10, so on. So 2 and 4 are even consecutive. 4 and 6 are even consecutives. Okay, so basically we need to use the fact that if n is a, let's say, whole number, whole numbers are the set 0, 1, 2, 3, ... So if n is a whole number, then 2n will definitely be even. Right, and you can experiment with that. So 2 times 0 would be 0. 2 times 1 would be 2, which is even. 2 times 2 would be 4, which is even. So if n is one of these numbers, then 2n will definitely be even. So I'll call the first even 2n. The next even, so if you think about what would be the next even after 2n would be 2n plus 2. Right? If this is 2n, if 2 is 2n, that means n would have been 1. And the next even comes from taking 2n and adding 2. Okay? So if this is the first even, 2n plus 2 will be the next even. The product of two consecutive even numbers, so meaning 2n times 2n plus 2, the product of those two consecutive even numbers, here's a even, here's the next even, so those are two consecutive evens, should be 360. So we need to solve this equation for n, and then we'll plug that back into here to actually find what the numbers are. So distributing, I get 4n squared plus 4n equals 360. Right, subtract 360. So 4n squared plus 4n minus 360 equals 0. It looks like I can divide out a 4, which will kind of make things a little bit more manageable. So n squared plus n minus 90 equals 0. And now I can solve for n. It looks like this happens to factor. So n minus 9 times n plus 10, right? So that does give this. Negative 9 times 10 is negative 90. Negative 9 plus 10 is 1. So I'm getting n minus 9 equals 0, or n plus 10 equals 0. So n needs to be 9, or n needs to be negative 10, but n can't be negative 10 because n is just one of these numbers. Sorry, left that out of the screen there. So negative 10, for that reason, I'm going to eliminate. It's mathematically true, but it doesn't actually fit this contextualized situation. So this would be n, and now what I do is I can take this n and plug it in right there, and also plug it in right there to actually find what these two numbers are. So the first would be 2 times 9, in other words 18 is the first number, the first even. The next even, if you take 2 times 9, you get 18, add 2, so the second would be 20. So those are consecutive evens, And 18 times 20 is indeed 360, like the problem wanted. Okay, so I'll go ahead and box these. Example 4, similar problem. So in this case, it's talking about odd numbers, and their product is 1023. So again, if n is a whole number, meaning 0, 1, 2, 3, and so on, then 2n will be even, so 2n plus 1 would naturally be odd. So we'll definitely be odd. All right, keep in mind 2n is even, so if you add 1 to even, you get an odd. So the first odd would be 2n plus 1. The second odd, or the next odd, I should say, just to match up. So I'll say next. The next odd would be 2n plus 3, right? Because we go 2 more, we have to go 2 more to get another odd. Just like we went 2 more to get another even. So what we're needing to solve is that 2n plus 1, the product of that and the next odd, should multiply up to 1023. This is the problem that we need to solve for n. Once we know n, we'll plug n here and here to actually figure out what these two numbers are. So FOIL, 4n squared. I get the outside as plus 6n, the inside is plus 2n, plus 3 is the last, and then 1023. Combine like terms, form a 0, solve with the quadratic formula, or factoring perhaps. So I'll subtract 1023 and I'll combine these two as well. So 4n squared plus 8n, and then I'm subtracting 1023 from 3, so I get negative 1020 now equals 0. Looks like I can take a 4 out of everything just to make my factoring or quadratic formula a little more manageable. So n squared plus 2n minus 255 equals 0. So I can maybe use the quadratic formula in this case. I'll use a is 1, b is 2, and c is negative 255. All right, so n equals the opposite of b, plus and minus the square root of 2 squared minus 4 times 1 times negative 255, all over 2 times 1. So I'll type that in fraction, negative 2 plus square root 2 squared minus 4 times 1 times negative 255 over 2. So it looks like I'm getting a 15 for n. So n plus equals 15. I'm going back and just seeing what the negative case is. So negative 17. N is not going to be negative 17 because n needs to be a whole number. So the fact that n minus equals negative 17, that's a 1, believe it or not. So negative 17, this one just gets thrown out because n can't be negative by assumption. So this is n. So now I can find the two numbers, right? Plug n in here. So the first would be 15 times 2, which is 30. So I'm getting a 31. And then the second, plugging in a 15 here now. Sorry, not there, but here now. So 15 times 2 again is 30. 30 plus 3, I'm getting 33. Right, so the first one, it looks like 31 times 33. Those are consecutive odds, and they multiply to 1023, like the problem wanted. So I'll box these answers and move on. So this will be the last one I do on the video. I'm going to leave example 6 open. Of course, I'll post a key alongside the video. All right, so example 5 says an arrow is shot vertically upward at a rate of 220 feet per second. This function models the height h of the arrow as a function of time, where t is in seconds. When will the arrow be 400 feet above the ground? So h is tracking the height. So if I want to know when it's 400 feet above the ground, I'm going to replace h of t with 400 and solve for those times. Might just be one time, might be 2 times though. Okay, so solving this, I want to subtract 400. So I get 0 equals negative 16t squared plus 220t minus 400. And here I can solve for t, right? I can use a of negative 16, b of 220, and c equals negative 400. So t equals opposite of b, so negative 220 plus and minus the square root of 220 squared minus 4 times negative 16 times negative 400 all over 2 times negative 16. All right, so fraction negative 220 plus square root 220 squared minus 4 times negative 16 times negative 400, or 2 times negative 16. I'm getting this number. Let's go ahead and round to 2 decimal places. So t plus, right, because I used the plus, equals about 2.16, and this would be a number of seconds, right? Since t is in seconds. Okay, go back, just press left a bunch. And I'm seeing, yeah, there's another time actually for which this arrow's at 400. So it must have hit 400 on the way up and then on the way down. So just to draw a quick picture, if this is 400 here, the arrow's going up, it's hitting right here at about 2.16 seconds, and it's going up some more and then coming back down and hitting 400 again at about, if you can see this number, about 11.60 seconds. All right, so it's going up, hitting here early, and then still going up, coming down now, and hitting 400 again. So it hits it on its way up and on its way down. T minus is about 11.60 seconds. So when will the arrow be 400 feet above the ground? About at these times. That's part 1. How long after launch will the arrow hit the ground? So for that, part 2, I'm now no longer interested in 400 feet. Hitting the ground, right, means I'm interested in 0. So 0 equals negative 16t squared plus 220t. I need to solve this equation. If I factor, I have t times negative 16t plus 220. Maybe I'll bring the rest of the work over here. Sorry about that. So what I need is that 0 equals t or negative 16t plus 220 equals 0, right? The zero product property. So I have that it was on the ground at t equals 0, but this question is how long after launch will it take the arrow to hit the ground again? So really that's coming from this one. So solving this one for t, I'll subtract 220. So I'm getting negative 16t equals negative 220, and then divide by negative 16. So I'm seeing t equals, on my calculator, I'm seeing 13.75 seconds for part 2. Okay, like I said, I'll do this one now and I'll post that solution alongside the video. All right, have a good one.